let's begin talking about hypothesis testing. So a hypothesis test is a series of tests in order to prove or disprove a claim. So when it says we're using sample statistics, it's going to be everything we've worked with in the past, mean, standard deviation, population parameter, etc., to describe population parameters such as the mean, proportion, variance, or standard deviation. So in this example, we have this car manufacturer here that advertises that the new hybrid gets 50 miles per gallon. We suspect that the mileage is not 50 miles per gallon. So we have two different opinions here. We have that the car does get 50 miles per gallon and that it does not. So the first step in a hypothesis test is to state the claim and then state the two hypotheses. Now, the claim can go with either the null hypothesis or the alternative hypothesis, and that varies from problem to problem. So we have to represent both sides here. So we will have the claim and we'll also have its complement. You can think of the complement as the opposite. So the null hypothesis, and this is important, the null hypothesis must always contain equality. So it'll have the symbols less than or equal to, or greater than or equal to. The alternative hypothesis does not contain equality and is the complement to the null hypothesis. So it'll use symbols like greater than, not equal to, or less than. So we read this symbol as H sub 0 or H naught for the null hypothesis and H sub A for the alternative hypothesis. So these are the three different combinations you can have for hypotheses. Now notice that the null hypotheses all contain equality in some form. The alternative hypothesis is the complement, meaning it covers everything else. So if you look at this first example, they claim the population mean is less than or equal to a number. So the alternative hypothesis would be greater than that number. These are some examples of the different phrasings that you'll see in the homework questions and when to use which symbols. So let's try an example. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Now we have to be careful with the wording of this statement, at least one. We really don't care how many activities these students are in. Think of it as a simple yes-no question on if you're in an activity, yes or no. So the school publicizes that the proportion is 61%, meaning exactly 61%. So let's write the claim and the hypotheses. Start with the claim. We are talking about proportion. Now the school claims that the proportion is 61%, so equal to 0.61. Now we write the hypotheses. Null hypothesis, alternative hypothesis. Now if we look at the claim does contain equality, so the claim will go in the null hypothesis. The alternative hypothesis is the complement to the null, or opposite. So either it's equal to, or it is not equal to. Okay. Let's look at another example. A car dealership announces that the mean time for an oil change is less than 15 minutes. So the dealership is claiming that the mean is less than 15 minutes. Start with the claim. Claim. They claim the mean is less than 15 minutes. Now, we do not want to put equal to here because they said less than 15 minutes, and 15 is not less than 15. For the hypothesis, the claim does not contain equality, therefore we'll move it to the alternative hypothesis. The complement is everything else. The mean is less than or equal to 15. Okay, let's look at one more example of this. A company advertises that the mean life of its furnaces is more than 18 years. Okay, so we're talking about these furnaces here. They claim that they last longer than 18 years. So they're claiming the mean life of the furnace is greater than 18 years. The claim does not contain equality, so we move it to the alternative hypothesis. Therefore, the null hypothesis will be the complement. If it's not greater than, the complement is less than or equal to 18. Okay, here's a visual representation of the complement. So here, this is where the null hypothesis is equal to, the alternative is not equal to. Here the null is greater than, so the alternative is less than. Here the null is less than, so the alternative is greater than. Now notice that you're going to have this kind of border in between, and it can go with either one or the other, but it cannot be in both. So these are the outcomes of the hypothesis test. Either we reject the null hypothesis or we fail to reject the null hypothesis. Now, what we have to be careful of are there are two outcomes we try to avoid: type 1 error and type 2 error. So a type 1 error occurs if the null hypothesis is rejected when it is true. A type 2 error occurs if it is not rejected when it is false. So let's look at this example here. We're talking about the USDA limit for salmonella contamination in ground beef is 7.5%. The meat inspector reports that the ground beef exceeds the limit. You perform a hypothesis test to determine if the claim is true. When will a type 1 or type 2 error occur? So we have this limit here. It says the limit for salmonella in beef is 7.5%. So if it's less than that limit, well, then it's acceptable. But if it goes over that limit, it is not acceptable. So P here represents the proportion of the beef that is contaminated. So they're claiming that it is above the limit, over 0.075. So the complement would be less than 0.075. So think of it this way. Less than the limit is good, over the limit is bad. So a type 1 error is rejecting the null hypothesis when it is true. So if this null hypothesis is true, that means it's under the limit, which is good. But to make an error, we would reject the null hypothesis, even though it's true. Now, if the null hypothesis is false, but we fail to reject it, well, that would mean that this is not true, meaning that it's actually over the limit, and that's bad. So in a type 1 error, you might be under the impression that the meat is bad when it is actually good. So what would happen is this meat would be removed from store shelves even though it's fine. Now in a type 2 error, we would be allowing product that exceeds the limit to be sold to consumers. So that's a problem. It means we're causing a public health problem when we're putting product out that is defective. Okay, level of significance. The maximum allowable probability of making type 1 error. So this will be changing from problem to problem. We have this Greek letter alpha here. So kind of like confidence level, the alpha value varies on how small you want the probability of an error to be. So common alpha values that we'll look at will be 0.1, 0.05, and 0.01. The probability of a type 2 error is denoted by this Greek letter beta. Now, we are not going to work with beta too often in this class. More often, we will work with the alpha value. Okay, so once we've stated the claim and we've stated the hypotheses, we collect sample data. We compare that to the test statistic. So we have these standardized test statistics, which are the same distributions that we worked with confidence intervals. Those are our good friends here, z, t, and chi-squared. Now, like confidence intervals, you'll have to read the problem to decide which of these distributions you'll use. Okay, so we have 3 different types of hypothesis tests. We have the hypothesis test for population mean. So we'll look at the sample mean. Now, just like with confidence intervals, we have this decision that we have to make, whether we're going to use z or t. And the criteria for that is the same. Whether the population standard deviation sigma is known or unknown. For proportion, we'll look at the sample proportion, and that will always use the z distribution. And then we have variance or standard deviation. We can run a hypothesis test for either, and that will use the chi-squared distribution. So we have the p-value. So this is the probability of obtaining an extreme data value. And this is what we are trying to avoid. We are trying to avoid the error. So there's 3 types of hypothesis tests: left-tailed, right-tailed, and two-tailed. the shape of this is dependent on the alternative hypothesis. Now this is important. Make sure this is in your notes. Whatever the alternative hypothesis is, tells us which of these tests we're going to use. So here's a left tail test. The p-value is the area in this tail. So the p-value is this blue part here. Now we'll use the same functions that we have in the past to find area or probability in order to get the p-value. So in this example, the alternative hypothesis says greater than, which indicates this will be a right-tailed test. Now, in this last one, we have an alternative hypothesis which is not equal to. If the alternative is not equal to, that is a two-tailed test. Now we have to be careful here. The p-value, this blue part, is split two ways, but it's symmetric and equal. So if we have the area in one tail, we'll simply multiply by 2 in order to get the p-value. So let's look at the examples we did earlier and determine what type of test it's going to be. So here we're revisiting the school that publicizes that the proportion is 61%. Now, the claim was that it is 61%. The claim contains equality, so we put it in the null hypothesis. The alternative is the complement, which is not equal. Because the alternative is not equal, this is going to be a two-tailed test. So the p-value would be this total area. Here, with the car dealership example. The claim was less than. There was no equality there, so we put that in the alternative. So the, I messed this up. This needs to be greater than or equal to. Now, for the type of test, we look at the alternative hypothesis. It is less than. Because it's less than, the p-value is on the left. Like so. And then finally, we have this company that advertises that it is greater than 18 years. So it claims that the mean is greater than 18. That goes in the alternative, so the null is less than. Because the alternative says greater than, this will be a right-tailed test. So the p-value will be over here. Okay, decision. Once we've computed the p-value, we compare it to the alpha value. If the p-value is less than or equal to the alpha value, we reject the null hypothesis. If the p-value is greater than the alpha value, we fail to reject the null hypothesis. Now, this is something very important, and this is something you'll need to have memorized for the homework and exams. Now, this table lists all 4 possible outcomes. This is not something I would expect you to have memorized. What I will give you, and this will be in Brightspace, is this flowchart. What this flowchart will do is it'll help guide you for the wording of the final conclusion of your hypothesis test. So what you'll do is you'll start here. Does the claim contain the condition of equality? If your claim does contain equality, you'll go to the right with yes or down with no. Then you'll see your decision. Do you reject or fail to reject the null hypothesis? If yes, you'll move to the right. If no, you'll move down. The solution to all of your hypothesis tests will be one of these 4 wordings, and you'll simply adapt it to the claim. So let's look at this example. We're back to the school. If we reject the null hypothesis, there's enough evidence to reject the school's claim that the proportion is 61%. If we fail to reject the null hypothesis, we can conclude there is not enough evidence to reject the school's claim that the proportion is 61%. So in the car dealership, so here, if we reject the null hypothesis, there is enough evidence to support the dealership's claim that the mean time is less than 15 minutes. If we fail to reject the null hypothesis, we conclude there's not enough evidence to support the dealership's claim. So let's run down all of the steps involved with hypothesis testing. So step number 1 is we'll state the claim and write the null hypothesis and alternative hypothesis. Specify the significance level alpha, and this will always be given to you in the problem. Determine which type of distribution to use. This will depend on the parameter that we're using, whether it's mean, proportion, variance, or standard deviation. Based on the hypotheses, we'll sketch whether it's left-tailed, right-tailed, or two-tailed. We'll calculate the p-value, and then we'll decide whether to reject or fail to reject based on the significance level. From there, we will use the flowchart diagram to get the wording of the final conclusion. Now, this last section, strategies for hypothesis testing, this is something you don't need to worry about in terms of setting up your own hypothesis test. You'll always be given this information on whether it needs to be the claim in the null or alternative hypothesis. All right, then that's hypothesis testing, and that's what we're going to do for the rest of Chapter 7. So what we'll do next is we'll look specifically at the 3 different types. We'll start with the mean. For the mean, we'll have 2 different types with Z and T. Then we'll look at hypothesis testing for proportion, which always uses z-distribution. And then finally, we'll look at variance and standard deviation, which uses chi-squared.